Okay, greater than, less than, or equal, and how do you know? First one, Parker.
3.
Read the number.
35,281 is less than 3. Is greater than 34,975 because in the thousands place the 5 is greater than 4.
Okay. And what I think I would look at here is I would just say, if you look at the first 2 digits of the number, 35,000 is more than 34,000.
Yeah.
That's maybe an easier way to say it. Elizabeth, the next one.
78,004 is less than 78,400.
Why?
Because 0, well, no number.
They both have 78,000, but this one has
a 4 in the hundredth place.
And this one has a
0.
Very good. Good job. Braden.
28,756
Because Yep. Again, I would say this has 28,000. This is 29,000. 29 is bigger than 28. These 3, last 3 for the mental math. Autumn, do the first one.
984,063 is less than 984,065 because in the ones place, 3 is less than 5.
Very good. Mackenzie, next one.
1,239,400,463 is greater than 1,239,362.
Very good. Slow down. Take your time. At every comma, you just say what the set is. You did a good job. Explain why.
Because there is a 4 in the hundredth place, and 4 is greater than 4.
Very good. Braylon, last one.
5,050,000
1,000 set. Very good. I like what you did. You're trying to do kind of what I modeled. So again, how I would do this is I'm just starting from the left and I'm working into the right as far as I need to when they're similar like this to say 5,400,000 is less than 5,410,000. You guys see that? I'm really only looking at these three places. So it's like I'm rounding. I'm not worried about the 780. 5,400,000 is less than, I really like the way some of you are paying attention because this probably isn't all that important. 5 million is less than 5,410,000. That's probably the easiest way to describe it. Okay, this is what we worked on yesterday. So if you weren't here, it may be difficult, but you got to try and remember about common denominators and things like that. It says which fraction is smaller, 3/8 or 1/5, or are they equivalent? Record your answer by using one of the symbols. So basically you're doing this. And then this will be a greater than, less than, or equal. Figure it out. We worked on it yesterday.
Mr. Ross,
Yeah, Autumn.
can I go now and I'll come back on later?
Yeah, you bet, Autumn. Whatever works. And if you don't get back in time, the rest of this will be on YouTube.
Okay.
Sounds good, kiddo. We'll see ya. Great. What I would think about doing is multiplying the denominators or multiplying the numerators. Whatever you do to the numerator, you do to the denominator. Whatever you do to the denominator, you do to the numerator. Here, Jeff, did it help? Did it make sense? Oh, good. Better than not making sense. You have until the timer runs out, then I'm going to start working on it. We got to find a way to start working faster. We need more time. Remember, I would look at the denominators. Is there a way to multiply 5 to get 8? No, so then I would take the fifths and multiply them by eighths. I take the eighths and multiply them by fifths. If you don't remember, I'll show you in about a minute when the sand runs out on the timer. There's really two ways to look at this. is you've got about 5 seconds to finish up. The first way, and probably the easier to multiply, but maybe the more difficult to think about in this case. Actually, I'm going to do the one that I think is easiest to think about. The first one is to look for common denominators. And that's, to me, the easiest way to do it. That's what we did yesterday. So what I do is I take both fractions and I write them. And then I do parentheses. Because what I always work with the smaller one first. That's something I said yesterday. I work with the smaller one first because I ask myself, can I multiply something times 5 and get 8? No, 5 times 1 is 5, 5 times 2 is 10, so there's no way I can do that. So then what I have to think about is there a way that I can multiply these and get the same denominator? And generally what you have to do, sometimes you get lucky and you can do a smaller one, but generally what you have to do is you have to take the 5 and put it over here. Whatever you do to the denominator, you do to the
Numerator.
Is people remembering this from yesterday?
Yes.
Okay, and then you take this 8 and you put it over here because this is how this works. I'm going to write my fractions again down here, but now they're going to have common denominators. Watch. 5 times 8 is
40.
and 5 times 8 is
40.
so I'm going to end up with 40ths. It's the easiest way to do this. Okay, especially because a step that I skipped here is I ask myself, is it more than half or less than half? This is less than half, and so is this. I've got a pretty good, if I were to guess, I'm going to say it's this one. But in order to prove it mathematically, having a common denominator helps. 5 times 3 is 15 out of 40. 1 times 8 is
8.
Now it simply just becomes looking at which one is more 40ths. If this cake was cut into 40 pieces, would you rather have 15 or 8?
15.
So it's 3/8. Now, if you go back to your original, this is the final step that sometimes kids don't do. If I go back to my original fractions, that means that 3/8 is greater than
1/5.
So there's some steps there. You can't be afraid of the steps. Okay? Way 2, which I think involves more thinking, would be to find common numerators, which I don't always like doing because I think you have to think a little more. So here's what I do. I start with my same fraction. And again, this time you start with the smaller numerator, which is also on the same side. And I think, is there something I can multiply 1 by to get 3?
Yes.
1.
3.
Do I have to do anything to this?
No.
No, because I already have a common numerator. So I get 3/8 is blank compared to 1 times 3 is 3. 5 times 3 is
15.
Okay, so now what I'm comparing is I have 3 pieces. There's 2 cakes here, okay? Out of one of them, you're going to get 3 out of 8 pieces. On the other one, you're going to get 3 out of 15. The larger the denominator, the smaller the pieces. So because these pieces are smaller, 3 bigger pieces is bigger than 3 smaller pieces. So 3/8 is bigger than 3/15. Now again, you have to go back to the original fraction. You guys see that? 3/8 is greater than 1/5. If you were writing this down as a number sentence, right? Those are these. Now, sometimes it's easier than that because you can, 9/10 compared to like 4/5. 9/10 is missing 1 small piece. 4/5 is missing 1 piece, but that piece is bigger. So 9/10 has more. Make sense? Okay. So now we're going to go to page, this is what today is all about. So we're going to page 86 now. All right. So taking a look at this, we have got these 5 fractions on each of these. And the first thing that I would do, if I were doing this, is I would look and I'd label them as either less than half, more than half, or exactly half, or an eighth. I'll show you that, but I'll model. We're going to do this first one together. First thing I'm going to do is I'm going to make it a little bigger so that we can see it on screen. So 4/10, what would happen? Now, what's the nice thing about this? Take a look at this. What's the nice thing about this one? This one, I don't even think we have to do that step. What is nice about this one? Well, Macy. Okay, so that means we have a common denominator. Okay, so therefore, all we have to do when you have a common denominator, we're going from smallest to largest, is put the numerators in order. If you wanted to start this, you could just go like this. Right across the board. You could write this neater than me on the line because it's probably easier to write in your book than it is on the smartboard. Okay, put them in order. All you have to do is write the numerators from smallest to this might be one of those times where when you're things to do and you're done with work, like I know that people have other things to do, but it might just be one of those things where you have to wait 35 seconds. Because otherwise I end up waiting 35 seconds to restart math once I redirect everyone. My dream is a day when I don't have to explain this. Okay, going in order. What would come first? Braxton.
1/10.
Okay, 1/10, because if you just have 1 out of the 10 pieces, that's the smallest one. I should probably do it in the color that we're going to see then. There we go, 1. Okay, what comes next? Quarter. Okay, because that's the next smallest numerator. Maddie, what comes next? Danielle? And Gavin. So something we should hope for if we ever have to order fractions on like a state assessment test or like a STAR test would be to hope and pray that we get common denominators, because common denominators make it super duper easy. And it's just counting. Next one. Oh, hey, oh, hey, whoa, whoa. What do you notice about this one? Don't flirt. Blake, what do you notice about this one?
They're common denominators.
This time we have common numerators. And so this one, do you really have to do the less than half, more than half probably?
No.
Okay, talk with a partner. What do you need to keep in mind when you're looking at common numerators? What's important to think about?
Yeah. Yeah. Yeah, I want to put the biggest denominator. Yeah, you're gonna go with this. Move the smallest.
Hadley, what do we need to keep in mind? Can you say that loud so it picks up on the computer audio?
The bigger the denominator,
Not the smaller the numerator. The bigger the denominator, the smaller the pieces. So in this case, when you look at it, just envision this because you guys have seen this. There's 1/4. There's 1/2. The bigger the denominator, the smaller your piece. So therefore, the fraction with the largest denominator will be the smallest. So which one should be the smallest one, Delia? 1/100th is the smallest, because that's like, if you can imagine a sheet cake that's in like a pan, it would be like if I brought one of those to school and I cut it into 100 pieces. Imagine how small the pieces would be. Very, very small, right? So Ava, what would be the next smallest? 1/12, because now imagine that sheet cake that I had cut into 100 pieces, but instead of doing that, this time I cut it into 12 pieces. Aren't the pieces bigger?
Yes.
Okay, so then what would come next, class? Actually, you finish them. We'll finish them right now. What would come next? 1/5, then?
1/4,
Then?
1/2.
Because as the denominator gets smaller, the pieces get bigger. Okay, so let's take a look at this next one. This next one has some common denominators in it, but something to recognize about all of them is that I would call them all at least similar denominators. But remember, I talked about that if you change them, you have to go back to the original fraction when you write it down. You guys understand what I'm saying? Okay, so I'm going to even make this a little bigger to see if we can fit it all on there so I have more room to write. There you go. Okay. Does anyone have an idea what we could do to make things? Okay, so first off, I guess maybe I should ask another question. What makes this a little challenging? Talk with your partner. What makes this a little challenging?
Well, because there's double, triple, the numbers, and the denominator and the numerator. Then there is big numbers.
Okay, what makes this difficult? What makes this a little more challenging than the other ones, Elizabeth?
The numerators and denominators.
Okay, so we have different numerators and different denominators. We can't just compare the numerators, and we can't just compare the denominators because 3/10, we're not sure how that compares to 45/100 yet. So who has an idea? Talk to your partner. What could you do to make this easier to compare? Maybe think about changing the numerators or changing the denominators and which one you would do and why.
Yeah. We probably have to change.
Delia, would you change numerators or denominators? What did you and Rajan talk about? Okay, why do you say numerator? Okay, what Ava has to say. Ava, what would you change? Why would you guys change why would you change the numerator? You want to change the thing that's the easiest, that's the most similar. Gary, I'd want to change the denominator because I can really easily change a 10 into 100. You want to see how? Watch how easy this is. I'm not going to cross it out. I'm going to leave it because I need this down here. Watch how easy I change this into 100. Because what would I need to do to change this into 100? Times 10. If I times this by 10, 10 times 10 is 100. Whatever you do to the
Denominator, you do to the numerator.
3 times 10 is
30.
okay. So figure out what this would be in hundreds. Go ahead. Good job. I heard somebody blurted out 16 hundredths. Now they all have common denominators. But what you got to remember is when you're thinking about this, you're thinking about it as 3/10, or it is 3/10, but you can think about it as 30 hundredths. So which one is the smallest one? Find the smallest one and write it in. Maddie, which one's the smallest one? Which one? 3/10 is 30 hundredths. Is that the smallest hundredth? 30 hundredths, is that bigger or smaller than 45 hundredths? Okay, 30 hundredths, bigger or smaller than 90 hundredths? Okay, 30 hundredths, is that bigger or smaller than 60 hundredths? 30 hundredths, is that bigger or smaller than 5 hundredths? I bring in that cake in a pan. It's cut into 100 pieces. Do you want 30 of them or do you want 5 of them? Or maybe an easy way to think about this is, do you want 30 pennies or 5 pennies? So which one's the smallest one, Maddie? 5 hundredths. Because when we have common denominators, you're just putting them in order of their numerators. And 5 hundredths would be the smallest. You look confused. Are you confused? Hey, are you confused?
No, I'm still get that.
We don't have 8/10.
On the first one.
But we're going from smallest to biggest today. Well, if you have 8, you're trying to make $1. If you have 1 dime, isn't that smaller than 8 dimes? Okay, I would love to trade money with you because I'll give you 1 dime if you bring me 8. Do you want 1 dime? Because 1 dime is 1 dime, 10 dimes make $1, right? So 1/10 would be 1 dime out of 10 dimes to make $1. Or do you want 8 dimes out of the 10? So 8 is bigger, 8/10, 8 dimes out of 10 dimes is more than 1 dime out of the 10 dimes to make $1. Same thing here. Now we're thinking pennies yet. And look, we changed 3/10 into 30 hundredths. Would you rather have 5 pennies? Because it takes 100 pennies to make $1, yes?
Yes.
Okay. This is like saying you have 5 pennies. This one's like saying you have 3 dimes or 30 pennies. Which one would you rather have? 30 pennies or 3 dimes, right? Okay. So now we've used this one, it's gone. Which one is the next smallest? Write it in. I really like the way you worked ahead. That probably will cause you to check out and not, which one comes next and why, Braylon? What? Okay, let's go through it one by one. It says 3/10 here. Hey, come here. It says 3/10 here, but I'm gonna think about it as 30 hundredths right now. Would you rather have 30 pennies or 45? Okay, so this one's smaller. Which one's bigger? 30 pennies or 90 pennies? 30 pennies or 90 pennies? Okay, I think you're telling me which one's smaller. What's smaller, 30 pennies or 90 pennies? Braylon, I walk over with 90 pennies and I plop them down in front of you in one pile, and I take 30 pennies and I plop them down in another pile. Which one is bigger? Okay, so this one's smaller, yes? Okay, we're really struggling with this, and I'm not sure where the breakdown is. So I'm really trying to like be really descriptive in this, that all you're doing, the denominators are common. So you just look for the next smallest denominator. 30 is smaller than 45. 30 is smaller than 90. 30 is smaller than 60. Therefore, which one is the next smallest one? Braylon. Okay, but we have to go back to the original fraction. So what would you write? Very good. I'm not going to worry about this one either now. Find the next smallest one. Which one is the next smallest one, Parker? 45 hundredths, because it's less than 60 hundredths, which is the same as 6/10. And it's definitely less than 90 hundredths. Okay, we only have two left. We have 6/10 and 90 hundredths. What is next, Porter? Why? So 6/10 is the same as 60 hundredths. That's less than 90 hundredths. Very good. Very good job. Which then leaves us with, whoops. Thank you guys for pointing out my mistake. You were being helpful. Awesome. All right. So now, how are we on that? How are we doing? Okay. Let's take a look at the next one. This is where it's going to start to get hard. Because this time, there's no real common numerator or denominator. So now is where I really need you guys to focus up and listen and work with me. This is where that first step of is it more or less than half, where it's really going to come into play and help you. You guys understand what I'm telling you? So let's go through these, and here's what I would do then. Before I do anything else. 3/4. More, less, or exactly half? 3, 2, 1.
More.
It's more. Because 2 out of 4 is half, yes? 4/5. More or less than half? 3, 3, 2, 1, class. Because I don't know what exactly half of 5 is, but I know 4 is half of 8, so it's definitely more than half of 5. 1/3, more or less than half. 3, 2, 1. Actually, you know what? 1/3, more or less than half, Mason. How do you know? One is half of 2, so 1 is less than half of 3. In fact, 1.5 is half of 3. Rajan, 4/8. It's exactly half. So this is the difference. This is where I put an H, because what does H mean?
Half.
H means half. 8/12, more or less than half. And how do you know, Braxton?
More because 8 is bigger than 6, and 6 is half of 12.
Very good. So now look at what we have. More than half, less than half, more than half. I think you could probably do something right now. What could you do, Mackenzie? What do you know based on what we just did?
There's 3 that I don't have, one that's less than half, and that's exactly.
So do you know what one goes here then?
Okay.
How do you know?
Because it's less than half.
And there's only one that's less than half, so therefore it has to be the smallest. Okay, do you see why this step is important?
Yeah.
Now, some of you may be able to do that without writing it down. But the reason that I would recommend writing it down, I'm also going to cross it out because I'm done with it now. The reason why I do it is then I don't have to remember when I'm comparing them. I can just look and go, well, there's only one that's less than half, so that has to be the smallest. It makes it so that you don't have to think as hard. Chase, what else could we do? Do we know what goes here? With 3/4, 4/5, 4/8, and 8/12. So we know what comes next. Which one? 3/4. Why? More than half, exactly half, more than half. Yeah, that's why it's important to be with us and thinking about the same things we are. Okay, why do we know that one has to come next, Chase? So if this is exactly half, it's got to be smaller than the ones that are more than half, yes?
Yeah.
Okay, now we're in that scenario where now we're going to have to do some comparing. Okay? This is where it gets a little bit challenging. One thing you could do is you could draw them. The other thing you could do is you could try and find a common denominator, which might be hard for all of them. So I'm going to give you a little suggestion here. This one, I have big pieces, right? But I'm only one away from being whole, right? This one, I have smaller pieces than this. So which one's bigger, 3/4 or 4/5?
3/4.
Which one has more filled in?
4/5.
4/5. So I know that this one, 3/4 is going to be somewhere, it's going to be one of, listen, 3/4 is going to be one of these two. Because 4/5 has to be bigger than it, right? Because if it's this one, 4/5 can go there. If it's here, 4/5 can go there, right? So the two that I'm going to compare are 3/4 and 8/12. And you know what the nice thing about those are? Can you make 4ths into 12ths?
Yes.
Yes.
So they're going to be easy to compare. Figure out how many 12ths 3/4. Go ahead and do that. What should I multiply the numerator and denominator by, Danielle? What do I need to multiply by here? Very good, Danielle. In order to change this to 12, I have to multiply by 3. 3 times 3 is? No, that's adding. That's just not listening. 3 times 3 is?
9.
9. 3 times 4 is?
12.
So what's bigger? 3/4 or 8/12?
4.
3/4 is bigger because 3/4 is the same as?
9, 12.
Okay. So which one should go next? Which one should go in that third spot? Which one should go in that third spot? Sadly. Very good, because it's smaller than 9/12. What should come next? Grade, what should come next? Very good, because we already figured out that 3/4 is less than
9, 4/5.
4/5. Good. Okay, last one, I think.
Nope. Wait. There's one thing at the bottom.
We're not doing it. What? Oh, that's a good question. That's more than one. So it's like having one whole plus.
Then
I'll explain in a minute. So here we go. They're adding a different wrinkle here. So I want to show you something. When you look at 3/2, 3/2 is equal to this. 2/2 plus 1/2. This is the same as 1 and
would have.
1/2. You guys see that? So here's what you do now. I don't really have a good lettering to do this, but when you look at this, maybe this time you compare it to 1. If the numerator is bigger than the denominator, it's bigger than 1. So, bigger than 1 or smaller than 1?
Bigger than 1.
Okay, bigger than 1. 4/6. Bigger than 1 or smaller than 1?
Small.
But more or less than half.
More.
So in our scale, less than half is the smallest. Half is exactly half. More is bigger than half. And B means it's bigger than 1. It's just a way to keep this organized. You understand that? 5/10. Is it an L, an H, an M, or a B?
8.
It's an H because 5 is half of 10. Okay, 120 out of 100. Bigger than 1. L, H, M, B. More than half. Okay, so you should be able to figure out which one is the smallest right now. Write in which one is the smallest. What one comes first and how do you know? Wait.
5/10 because that's the only one that's not bigger or more than 10.
Yep, it's exactly half, and that's the smallest one we have. Now, what I know now, check this out. What I know now is that it's either going to be 4/6, these next two are 4/6 and 3/5. And I'm not telling you which one's which yet. But one thing I do notice is that they're both missing the same
Amount of pieces.
number of pieces. They're both missing 2 pieces. The smaller one is going to be missing the bigger pieces. Which one is missing bigger pieces, 4/6 or 3/5? Don't flirt. Gavin, which one's missing the bigger pieces? 3/5. So that means if it's missing 2 bigger pieces, that means it's missing more, right? So that means it's smaller. So the next one should be what, Gavin? Hey, you know what that does for me? It lets me know which one's the third one. Yep. What wants to come next? Braylon. 4/6. Okay, so now what I know is that these next two, I know they're both bigger than one, and I have to figure out which one's bigger. So look, over here, I know that it's 1/2 and 1/2. You see that?
Yeah.
We're going to do the same thing. I have 120 100ths. What would the whole be?
100.
100 over 100 plus 20 over
100.
100. So this is like equal to 1 and 20 hundredths. Who said what? Macy, is 100 out of 100 one whole? That's where I get my 1. Because I have an extra 20, I got to put that over the same denominator, 20 over 100, yes? Okay, so now what I'm comparing is 1 and 1/2 to 1 and 20 hundredths. Is 20 hundredths more or less than half? Less. Because half would be, what would this have to be if it was half?
10.
50. 50 out of 100, yes? So which one's smaller?
120 hundredths.
Yes, 120 hundredths, because if this were equal, 1 and 1/2 is equal to 1 and 50 hundredths. So your next one should have been 120 hundredths versus 3. All right, very good. I think you guys worked pretty hard on that. I think that that's a challenging thing to do. I don't think that we have time. I don't think we have time to necessarily do the placing numbers on a fraction line. We'll probably do 87 tomorrow along with 84. Those will be our 2 pages for tomorrow. We are going to look at 88, which is your math boxes. Okay, we're on math boxes. I like the way that some of you are staying on task and not being distracted by other things, like books. Okay, finding equivalent fractions. So they want 2 names for 2/4. Here's what they want you to do. I'm going to show you the easiest way that I know how. Sometimes you can split them in half. Like if you look at 2/4, I can split them both in half. But generally what you probably need to do is this. Bigger, I guess. I take that and somewhere up here I would write, probably not with blue. This is the easiest way to do it. 2 times 2, 4 times 2, and you should get an equivalent fraction. Right? Same thing down here. 2/3. Whatever you do to one, you got to do to the other. What if you didn't want to do 2? Do 10, do 5, do 6. Whatever number you put in, though, just make sure it's the same and multiply across. 2 times 2, 3 times 2, and get a new fraction. This is as easy as I can make it. Question on number 1.
No.
Which shapes have perpendicular sides? So it's only going to be one of them. A, B, or C, perpendicular. Shapes A and B, shapes B and D, shapes A and C. Okay, here's where people get this one wrong. A lot of people get this wrong. Tons of people get this wrong. Miss Kessler needs ceramic tiles for an art project. She has 1 24 pack. So what that tells me is that's just like 24. But she has 2 12 packs. That's like plus 2
Times 12.
1 pack of 18. Then she returns 16 tiles. What do you have to do with the ones you return? You're going to have to subtract after you do all that adding. Questions, comments, or concerns about that? All right, none on there, huh? You need help, make sure you ask. This is just writing it in regular form, so I'm going to give you the answer for A, so everyone should get this point. I have 6 thousands. I put a 6 in my thousands place. Then it tells me I don't have any hundreds. That's supposed to be a 0. So I put a 0 in my hundreds place. I have 3 10s and 4 1s. You guys understand how to do this one? Okay, shouldn't take you long. Okay, top one's pretty self-explanatory. But here's the difference. When I've taught you to do this, I say you count until the first whole number. So watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See how you get your 10 for a denominator? Here's where kids mess this one up. 1, 2, 3, 4, 5, 6, 7, 8. But you're counting from 0 to 2. They've already given you the denominator right there. Your denominator should be 1, 2, 3, 4, because you're going to the first whole number. There's a couple different options for how you could write these ones. Okay? It's work.